Guys, this is test 35, game 2. This is the cars and options game. I have laid out the game as such that we have the cars as our base, and we are assigning the options to the cars. I've done this because the rules tell us more specifically about the cars than about the options. The first two rules here talk about both cars and options, but the remaining rules are all specifically regarding the cars. So I've laid out the cars T, V, W, X, Y, Z as our base, and we are assigning the options P, L, S, power, leather, and steering to the cars. So the first rule tells us that V has P and S, so I will establish P and S above the car V. Next, W has P and L, so I will assign P and L to W. Next, they tell us that W and Y share nothing. So because W has both P and L, and every car has to have at least one option, I'm going to put S over Y, and I'm going to box it off because Y cannot have anything in addition to S. And W is boxed off as well because we can't have anything in addition to both P and L over W. Whereas V could, at this moment, have P, S, and maybe even L as well. When the first rule told us that V had both P and S, it could have had L as well for all we know. Next, they tell us that X has more than W. W has both P and L, two options, so X is going to have P, L, and S. It's going to have all three of the options right now. Next, V and Z share exactly 1, so I'm going to put down on the side V and Z equal 1, meaning they have one option in common. Again, because V could have P, L, and S, we don't really know what it's going to share with Z at this moment. It's still ambiguous. But the next rule tells us that T has fewer than Z, and because each car has to have exactly at least one option, Z has to have at least two options at the moment. And so we now learn that V could not have all three options. It has to have only those two, P and S, because if V had all three options, it would share at least two options with Z, not only one. So now we learn Z will have exactly two options as well. It cannot have all three, because if it had all three, then it would have more than one option in common with Z. So Z is going to have one of P or S, and then it will have L as well. Now, because Z has exactly 2, T will have exactly 1, and that one option could be any of P, L, or S, and this is our setup for the game. Question number 6, how many cars can we determine exactly which options each car has? So both T and Z are rather ambiguous. We have slashes regarding those two cars, T and Z, so we don't know exactly which options those cars have. However, V, W, X, and Y are all completely and fully determined. So for that reason, 4, V, W, X, Y is our answer to number 6, and as such, C is our answer. Next, number 7, general must be false question. So 4 of these options could be true, one of them cannot be true. So we can find the 4 options that could be true, eliminate them, and whatever remains will be our answer. A, 5 cars have leather. Well, T, W, X, and Z could all have leather, but that's only 4, not 5. So A is actually our answer to number 7. However, I will go through the remaining choices. B, exactly 5 have sunroofs. T, V, X, Y, and Z, that's 5 cars that could have sunroofs, so B is possible and is eliminated. C, exactly 4 have leather interiors. We could have T, W, X, and Z all having leather, that is 4, so C is eliminated. D, 4 have power. T, V, W, and X could all have power, or V, W, X, and Z could all have power. So either of those options would allow us to have 4 cars with power, and for that reason, D is eliminated. E, 4 have sunroofs. We could have T, V, X, and Y, or V, X, Y, and Z. In either of those cases, we could have 4 sunroofs. So for that reason, E is eliminated, and A is our answer to number 7. Next, number 8. If all the cars that have leather also have power, what must be false? So if all the cars that have leather also have power, T could not have leather, because then it would also have to have power, and T can only have one option. So for that reason, T will have either P or S, and Z will have both L and P, because it definitely has to have leather. So for that reason, we should scan the cars as such. T has P/S, V, W, X, and Y remain as they always are, and Z has both L and P. So kind of make an arc with your eye or with your pen as you are looking through these different cars and options. So this question is a must-be false question. Must T have power? No, it could have a sunroof, so A is eliminated for number 8. B, T has a sunroof? No, it could have power, so for that reason, B is eliminated. C, V has power. V, of course, will always have power. V has both P and S at all times, so C is eliminated. D, Z has power. Z, yes, Z has to have power, so of course that could be true. In fact, that must be true. D is eliminated. E, Z has a sunroof. No, Z is not having a sunroof in this case. It is specifically having both L and P, not S. So for that reason, E is our answer to number 8. Next, number 9. If Z has no options in common with T, but at least one option in common with every other car. So Z and T share nothing. Our 2 ambiguous cars share nothing. So for that reason, T will not have L. It will have either P or S. And Z will have both L and then with whichever other option T does not have, meaning S or P. Now, they specifically told us that Z shares an option with every other car. So for that reason, Z will have to have S and T will have to have P. Z is going to have both L and S, and T is going to have P specifically. So every car is now fully determined, no ambiguity at all. Now they're asking us what must be false. Must be false means could be true except. 4 of these choices could be true. 1 of them cannot be true. T has power. Could that be true? Yes, it could be true. In fact, it is a must. So for that reason, A is eliminated. B, Z has a sunroof. Again, that is a must. So for that reason, B is eliminated. C, 4 have power. T has power. And then V, W, and X all have power as well. So for that reason, C is not only a could, is in fact a must in this case, and C is eliminated. D, 4 have leather. Well, W, X, and Z all have leather, but that is only 3, not 4. So D is impossible. It is a must be false. It could not be true, and it is our answer. I'll go through E though. 4 have sunroofs. Well, we see that V, X, Y, and Z all have sunroofs, so yes, we have met the condition of having 4 sunroofs. That certainly could be true. It is eliminated, and D is our answer to number 9. Next, number 10. If no 2 cars have exactly the same options as one another, what would happen? Well, W has both L and P, so for that reason, Z cannot have both L and P. Z will have to have L and S. And because Y has S, T cannot have S. It will have either P or L. And this is the state of affairs for this question. Now they are asking us could be true except. 4 of these could be true. 1 of them cannot be true. Could we have exactly 3 cars with power? Yes. If T had L, our three power cars would be V, W, and X. So yes, that is possible, and A is eliminated. B, 4 have power. If T had power, we would have T power, V, W, and X all power as well, and yes, we would have 4 power, so B is eliminated for number 10. C, 3 have sunroofs. Could that be true? Well, V, X, and Y all have sunroofs, but Z has to have a sunroof as well. So for that reason, we will always have 4 sunroofs in this case, not 3, and C could not be true. It is a must be false and is our answer to number 10. I'll go through the others though. 4 have sunroofs, V, X, Y, and Z all have sunroofs, so that is a could be true. In fact, it is a must be true. So D is eliminated for number 10. And finally E, 4 have leather. Could that happen? Well, W, X, and Z all have leather for certain in this case, and T could have leather as well. So for that reason, we could have 4 leathers, and E is eliminated for number 10, leaving C as our answer for number 10. Next, number 11, if 4 have leather and 4 have power, must be true except. So if 4 had leather, we already have Z, X, and W all having leather. So to reach 4, T will have to have leather as well. Now, we also have to have 4 power. So V, W, X have power. Z will also have to have power, so Z is both L and P in this case. Must be true except question. 4 of them must be true. 1 of them does not need to be true. So we find the 4 that must be true, eliminate them, and whatever remains is our answer. T and V have no options in common. Must that be true? Yes. T has leather, V has both P and S, they share nothing, so A is eliminated for number 11. B, T and Y share nothing, T has L, Y has S, they share nothing, so B is eliminated for number 11. C, T and Z have exactly 1 option in common. T has L, Z has L, they only share L, nothing else, so C is a must and is eliminated as a result. D, W and Z have exactly 1 option in common. W has both P and L, Z has both P and L. They share exactly 2, not 1, so D is our answer for number 11. It is impossible for them to share only 1 because they share 2. I'll look at E though. Y and Z share nothing. Y has S, Z has both P and L, they're not sharing anything. E is eliminated for number 11. Next, number 12. This is a rule suspension question. We are fundamentally changing the rules of the game. X does not need to have more than W now. Instead, they share exactly 2. So for that reason, they will have both P and L. Both W and X share P and L. X no longer needs to have S, although it could. So for that reason, I will draw a dotted line between S and to both L and P for X. X could have S, yet does not have to. Now this is again a must be false question, meaning could be true except. So 4 of these choices could be true, 1 of them cannot be true. Could T and X have no options in common? Yes, if T had S, X could have both P and L yet not have S, so they could share nothing and A is eliminated. B, V and X share exactly 1. Yes, they could share only P if X did not have S, and that is possible, so B is eliminated. C, V and X have exactly 2 options in common. Yes, they could share both P and L and share nothing else, so for that reason, C is eliminated. D, X and Z share nothing. So X and Z both have to have L. Yes, they both have L. X has L and Z has L. Those are definites, so they could not share nothing, and D is our answer for number 12. I will look at E though. X and Z have exactly 2 options in common. Could they have exactly 2 options in common? Well, X has both P and L. Z could have both P and L. So for that reason, this does not have to be false. it could be true, and E is eliminated, leaving D as our answer for number 12.